So today we're going to do the ratio test. As a heads up, this one's a good bit of writing a little bit, and you write the same thing kind of over and over a lot, but I tend to like it because I can write the same thing over and over. That's not bad, you know. So just like I'm just letting you know ahead of time, you're going to write a little bit for this, and maybe kind of try to write small because you don't have that much space. So if you do the limit, and my arrows are backwards, I'm really sorry. You know what I mean, though. It's not as infinity goes to n. That wouldn't make any sense. Limit is n goes to infinity. And what you do is the numerator is a sub n plus 1. So you plug in n plus 1 everywhere that there's an n. And then that goes over a sub n, which is just you repeat the problem. If that is smaller than 1, the series converges. If that is bigger than 1 or goes to infinity, the series diverges. And if it equals 1, then it's no conclusion. That's essentially it. It's just getting that is kind of a lot of writing, right? So we all buckled up. Limit as n goes to infinity of a gigantic absolute value. Now here's my advice. You can write this however you want, but what you're going to end up with is a fraction and then another fraction with a fraction bar in between. Like, are you following me on this? Okay, so what I do is I make the fraction bar that's in between the two other fractions extend all the way to the absolute value bar. I make them touch so that I can tell which one's which. That's my 2 cents on that, because otherwise it just looks like a complete mess, right? We are going to plug in n plus 1. So you will have 2 to the power n plus 1 over n plus 1 factorial. Over, and do you see how I made that one touch the absolute value bar? That's my suggestion. You can like do whatever you want. Like that helps me keep it organized, because this is really mostly about organization. And then underneath of that is the problem, like just copy it. Now, some of you are brainiacs and will probably end up skipping that step, and I'm fine with that. I'm going to write it every time because for me, it's not an intelligence thing, it's an organizational thing, and I will lose what I'm doing if I don't write it. But every single time, what's going to happen is you're going to multiply by the reciprocal. When you divide by a fraction, you multiply by the reciprocal. So if you want to skip straight to this next step, you can do that. I'm never going to do that, though. You want to make everything kind of line up where it goes. So you're going to have 2 to the power n plus 1. Now, this n factorial is going to go in the numerator. Again, we're flipping that. And then everything else goes underneath. But you want to put the 2 to the n first, because do you see how I now have those lined up? And then the n plus 1 factorial. So again, if you feel comfortable skipping that first step, you can. I'm going to recommend against it. It doesn't take that long to write out. I get that it's a little bit annoying, but I would rather write it and get the problem correct than not. Now we're going to cancel some stuff. Stuff will always cancel when you do this. So we're going to see what cancels out, and then we'll evaluate the limit and see if it's bigger or smaller than 1. So when you have 2 to the n plus 1 over 2 to the n, 2 to the n means 2 times 2 times 2 times 2 times 2 times 2 n times. In the numerator, you just did it n plus 1 times. So all those 2's would cancel out except one of them, and it would be in the numerator. So we have a 2 that's in the numerator, because here's what happens. As many times as you want, but like these cancel, and then you have like that 1 left. Okay, this is going to happen a lot, and I can't go through that explanation every single time, so you're going to have to like be on board. The same thing is going to happen with the factorials. You're going to have n plus 1 left, because the way a factorial works, like for example, like say in the numerator you had 5 factorial, and in the denominator you had 6 factorial. Do you see what's going on there? These all cancel, and you just have that n plus 1 left in the denominator. Again, that's going to happen a lot, so get used to it. That's how it cancels out. Now we're going to evaluate the limit. So this is how this works. You write it out, you flip it, you cancel things, and then you evaluate the limit. As n goes to infinity, what are we going to get? 0, which is bigger or smaller than 1 last time you checked. Smaller than 1, so this converges by the ratio test. That is essentially it. We're just going to practice it a bunch more times. It just gets like bogged down with all the writing. All right, limit as n goes to infinity. So we're going to plug in n plus 1. So you're going to have n plus 1 squared times, 2 to what power? If you plug in n plus 1, good, it'll be n plus 1 plus 1. So n plus 2 over 3 to the power n plus 1. So you plug in n plus 1 everywhere that there's an n, and then underneath of that, just copy the problem. And again, that's where I make the fraction bar touch the edges, because I don't know, that just helps me. All right, so then we're going to write limit as n goes to infinity, and then here's where you're going to flip over the denominator. You're multiplying by the reciprocal. So again, it's about staying organized. In the numerator, we're going to have the n plus 1 squared, the 2 to the n plus 2, and then what else is going to go up on top? The 3 to the n, good, because this is getting flipped. Everything else will go in the denominator, so like all of this stuff. Or if you want to think of it as like the outsides and the insides, like the outside stuff goes on top and then the insides, yeah, me too. That's how I think of it too. So these will go in the denominator, but you want to line them up. So you want the n squared to come first, and then the 2 to the n plus 1, and then the 3 to the n plus 1. So make them line up with the ones that go together. Then you cancel out, and then you evaluate the limit. Now, n plus 1 squared and n squared, you really can't do anything with, because if you were to multiply this out, it would actually be n squared plus 2n plus 1, like if you expand that. So there's really nothing we can do with those, unfortunately, so just leave those alone. Now this is like what we had in the last problem. Think about all the 2's that we had out there. You're gonna have 1 2 left over, and where's it gonna go? On the top, good, because that's where you have like the extra one. That's what happens a lot with this, is you're just deciding where the extra thing goes. Same with this, you're gonna have an extra 3 on the bottom. And now we're gonna evaluate the limit. So limit as n goes to infinity. Now in the numerator, you would have an n squared. In the denominator, you would have an n squared. When the powers are the same, you use the coefficients. I don't have them written out front, I have them written off to the side, but these would be your coefficients. So it would be 2/3, and I'm almost out of space, but 2/3 is less than 1. Phew, barely made it. So this converges by the ratio test. These actually aren't bad. Again, it's a bit of writing, but like once you get good at this, you can kind of just turn them out because they turn out the same way every time. Like you write it, you flip it, you cancel, you evaluate the limit. Oh, this one's interesting. You might not like me with this one, but I'm going to do this problem anyway because I think it's cool. I think this problem's cool. You might not, but I do. All right, we're going to plug in n plus 1. So you would have n plus 1 to the power n plus 1. That's cool. Over n plus 1 factorial. And then that all goes over the problem, yeah. So far? Well, I've got to make it a little bit more interesting because like when we did problem 1 and 2, you guys are probably like, okay, we got it. I got to spice it up a little bit. You know what I mean? All right, so we're gonna flip the denominator. So it's going to be n plus 1 to the power n plus 1 times n factorial over n, oh, this is not n squared at all. It's n to the nth. Whoopsie. Copy error. Over n to the nth times n plus 1 factorial. So let's see what we can cancel out. I'm hoping I have enough room. I'm gonna have to go back down to the next line eventually. I was looking at how I worked it out here and seeing how much room. I have a hole in the paper, so I don't know if I'm gonna be able to make this fit, but n plus 1 to the power n plus, yeah, you know what, none of that's gonna cancel because that's n plus 1 and that's n plus 1. So we're gonna have to just copy that down. But the other part, that's similar to the one we did on the other side. All that's going to cancel except for the n plus 1. Phew, made that fit. So now we're going to look at these. Do you see how we have n plus 1 to the power n plus 1? So one of them is going to cancel. And it will just be n plus 1 to the nth. One of the n plus 1s is going to cancel. So basically getting rid of that plus 1, like that extra one. So this is what canceled out there. I think this one was the exact same, wasn't it? No, you're fine. Where did we do one like that? Right here. So it's just like that. The example I used was the 5 factorial and the 6 factorial. Like if you list them out, everything cancels except that very last number. So all that's left is that n plus 1. And then I canceled out one of those. So instead of n plus 1, it's just n. Do you see how these are both to the nth? This to the nth and then that to the nth. So I can write it as the whole thing to the nth. Almost there. You're going to be okay. I like how this one turns out. It is. So n over n would be what? 1 plus 1 over n to the nth. Does that look familiar to anyone? Or does anyone remember that? We looked at it pre-calc, but that's like a million years ago. Do you know what that goes to E? That's a famous limit. 1 plus 1 over n to the nth. That's the pattern that if you take that out forever, you end up with 2.718 ... So anyway, that goes to E, which is greater than 1. So this diverges by the ratio test. I mean, I had it on there like from before. We'll do one more together and then I'll let you guys try one. All right, limit as n goes to infinity. I know you're all excited. Now we're going to absolute value this. So do I need this part? No. Yeah, exactly. But we're going to turn them all positive. So you don't need that part. So this is going to be square root n plus 1 over n plus 2. Good. It's n plus 1 plus 1. So again, you plug in n plus 1 and then it's over the problem. And your allergies are killing me. No, you're fine. I just feel bad. I think everybody is really bad this year. All right, so we're going to flip this. So the n plus 1 will go to the numerator, and then everything else is in the denominator. But again, you want to make them like line up. No, nothing cancels there, unfortunately. But actually, the good thing is we don't have to do any more writing, and we can just go ahead and evaluate the limit. Square root means n to what power? 1/2. That's n to the 1/2 times another n. That would be n to the 3/2. And down here, same thing. If they're both n to the 3/2, that means the powers are the same. You would use the coefficients. What's in front of here? 1. It's 1 over 1, which is 1, which is a gigantic bummer because what does that mean? We don't have a conclusion, so we are totally back to the drawing board, okay? Actually, let me go ahead and write that, no conclusion. But what does this -1 to the n mean? Because Jenny, you kind of brought up alternating. So let's do the alternating series test. What does that say? Okay, so that's the first part. Let's do that. Limit as n goes to infinity of square root of n over n plus 1. We need for that to go to 0. Does it? Yes. This is to the 1/2 and this is to the first. If the numerator is smaller than the denominator, it's going to go to 0. Phew, so far so good. What's the other thing that has to happen for the alternating series test? +1 has to be less than or equal to, good. Okay, basically the terms have to keep on getting smaller. So let's plug in n sub n plus 1. Now I started it at 1. I'm going to plug in 1 and see if that's true. It actually doesn't matter where you start as long as it's true eventually, because we're going out towards infinity. But if you plug in 1, let's see, the right side would just be 1/2. The left side, you'd have square root of 2 over 3. I don't know what that is off the top of my head. I think it's smaller. Yeah, because square root of 2 is like 1.4 something. Yes, it is smaller than 1/2. Okay, so that is true. So what's our grand conclusion to the whole thing? Converges by alternating series sets. All right, so if you go to cancel out, you really can't do anything with the n plus 3 over n plus 2. But here, what will this reduce to give you? Good, you'll just have an n plus 1 in the denominator. So that's just what's left over. Then you can evaluate the limit. This would be n, just n to the first. If you multiplied these out, you would have n squared. So if you have n to the first over n squared, that limit to infinity is 0, which is less than 1. So what's your big conclusion? Perfect.